Hey everyone, good morning. Good morning, Strange Loop. Hopefully by now some caffeine has sunken in, I hope. By the way, feel free if you want to take any pictures, that's totally cool. Permission granted in advance. Today I'm going to talk about GraphQL, which is a query language for APIs that we've developed at Facebook as a replacement for REST APIs. I'll introduce GraphQL a little bit for those who haven't had an opportunity to check it out yet. But really what I want to focus on today is actually the problems that led us to GraphQL and the process of developing it over the course of the last 4 years. And I hope that some of the lessons that I learned in the process will be relevant to all the stuff that you guys are building every day. So my name is Byron, and I work on a team at Facebook called Product Infrastructure. Our team's responsible for building the libraries and the tools that help our teams build great products. I also work on a lot of our open source libraries. So I was an early contributor to React. I'm the creator and maintainer of Immutable.js, and I'm a co-creator and the maintainer of GraphQL. In product infrastructure, we run our team like a service. We're always working super close to product teams to make sure that we're seeing the real problems that they're running into on a regular basis. And 4 years ago, we were working really closely with our iOS newsfeed team. They were working on a new version of our iOS app, and they were struggling with actually just retrieving data from our servers. So that's where we wanted to go focus. That problem ultimately led us to develop GraphQL, which over the last 4 years has become the major way that we retrieve data, not just for newsfeed, but for all of our mobile apps. And I know a lot of you haven't seen GraphQL yet, so I'll just briefly show you what it feels like to use GraphQL. This is the hello world of GraphQL queries. I want to know my name. I don't know why I forgot it, but this is how I'll get it again. The first thing you'll notice is that this looks a little bit like JSON, right? You've got these curly braces. They look kind of like JSON objects. We call them selection sets. And then within those things, you have stuff that they look a little bit like object keys. We call those fields. And fields themselves can have selection sets, which lets us describe deeply recursive or nested data. We send this query as a string to a GraphQL server where it's parsed and it's executed, and it gives us back a response that looks a little bit like this. And you can see that the response and the query have the same structure. And this is an important part of why GraphQL is easy to learn and use. A GraphQL query describes the shape of the resulting data that you'll get. But of course, we can request fields that have complex values. So here, profile picture is a complex field. It's got information about the width and height of the image that we're going to get, as well as the URL that we're going to need to go load. And I bet you can already guess what this is going to look like when we run it, right? It's going to share that same shape. And it's important to point out that in GraphQL, you have to query down to individual scalar leaf nodes. So there's no equivalent of like select star. This ensures that there's zero ambiguity in what you're going to get and what information is needed so that no changes on the server could ever affect the outcome of what this query is going to be. That ends up being super important. And you're going to get exactly what you ask for. You're going to get nothing more and nothing less. But of course, and most importantly, GraphQL is designed not just to query the properties of one thing, but to smoothly follow connections between them. So for example, if I want not just my name, but the names of all of my friends, I might write a query like this. And notice that here's where SQL would require some join operations. Or a REST API might expose a list of URLs, so we'll have to go back and load in another round trip. GraphQL lets us represent this in a way that's easy to understand and can be done in a single round trip to the server. Also notice that when we ask for one field here, we're going to get it on every single item that comes back in that list. So it's kind of like running a map operation across a list of things. And of course, we can do this as deeply as is necessary for whatever the data needs that we have for the app that we're building. So if I want not just my friends and their names, but I want the events that they're attending next, I might write a query like this. We can continue to do this and naturally represent these queries at deeper levels. And we can also pass arguments to fields, and this is an important feature. This lets us customize the behavior of these fields. The most common example of doing this is to paginate over lists. So here I just want my first friend and the next event that they're going to attend. And this kind of query shows up all the time in Facebook's apps. We have tons of interrelated data that all appear in a single view. And it's critical that our mobile apps can show this kind of thing and do it over a typical, slow, high latency mobile network. All right, so this is going to bring me to some of the motivations and what led us to actually do this in the first place. Why did we build a new thing? Well, the original motivations for GraphQL were efficiency and predictability, and we've already seen these two in action just with a couple hello world queries. Facebook's newsfeed is full of interrelated stuff, and the ability to request and retrieve that in one round trip was huge. Another big challenge that our iOS engineers were trying to keep track of was exactly what data is going to come back from our REST APIs. They were using our REST APIs before, and they faced tons of subtle bugs when they made some assumption of what the data shape was going to be coming back, and they were wrong. With GraphQL, the shape of the data is known. It's easily derived from the query, and later that actually enabled us to use code generation for our model classes to completely eliminate that kind of problem. And another benefit of GraphQL is that it's backed by a static type system. And I feel like I probably don't need to elaborate the benefits of that to this crowd. But what we actually want to do when we're building a GraphQL server is define this type system. And that sets up the capabilities of our API. And as we were doing this, we were inspired by RPC systems like Captain Proto or Thrift. So let's take another look at that query from before. I kind of glossed over something. How do we even know that this is an OK query to run? Well, the type system told us that it was. Within every query, we can compare it to the type system that our server defines. And at the top of every request, we have a root type. We typically call it the query type. And it defines all the things that we can kind of start with. And so here we're asking for me, which is probably the logged in user, and it's going to return to us a user object. From there, we can kind of fold in. We can get deeper into these fields. And we can see that the type system describes both the fields and the arguments that are available with types all along the way. And in doing so, it describes not just what's possible, but it also describes what's not possible via omission, right? So unlike SQL, which lets you perform kind of any arbitrary operation across any column in your table, GraphQL only describes what you tell it it's going to be allowed to do. This is going to help us make sure that our GraphQL servers are performant, right? So we're only sorting on indexed columns, or we're only filtering on things that are easy to filter. But also, it makes sure that we actually think about how we're designing our APIs, that we separate it across from our databases. And it gives us an opportunity to make sure that we understand what we're trying to share and what we're not trying to share. So let's continue. We asked for friends, and we were going to get back a list of users. Lists in our type notation is done with these kind of square brackets. And now we can ask the name of our friends and the events that they're attending. And events is going to return a list of the event type, and then we can ask for the names of those events. So by having this type system, we're able to prove that this query is valid before we even attempt to run it. So is this query valid? No. It's not valid, right? Like a user doesn't have attendees. That doesn't make sense. An event does. And of course, like we're smart people, so we can spot this mistake. But importantly, the server can also spot this mistake. So without executing the query, the type system is used to determine if this query is invalid or not, and it can return a useful error if it is. And not only can the server know these things, but the client can as well, because GraphQL supports introspection. So that means that you can query information about the GraphQL types on your server with GraphQL. And this is super amazing for building tools, because we can build things like rich IDEs that not only tell us if our queries are valid on the client, but it also lets us interact with them in a way that we would hope a best-in-class IDE would let us interact with our own code bases. And we actually built and released a tool that does exactly this. It's called Graphical. And it's an IDE in your browser that helps you write and test queries against your API. It highlights issues, it has type-ahead completion, and it even has an integrated documentation explorer. And by the way, documentation is a first-class citizen in GraphQL. It's part of the introspection query. And that's super helpful when you're keeping documentation up to date with your code, because it actually lives in your code rather than some other website or wiki or some other source you have for your documentation. And finally, and probably most importantly, is that it gives more power to clients to allow APIs to provide features sooner. Typically, when using something like REST or most other web APIs, The server is going to be responsible for the shape of the data that's going to be returned, and the clients are going to be responsible for the views that they're going to render. So the client's going to ask for some resource, and then the server's going to respond with the data that represents that resource. But what happens when our app needs to add some new feature? It's going to require maybe some new data from that resource. And it turns out that models and views are actually pretty tightly coupled. So we're going to have to go to our API team or into our API code and figure out how we're going to change that. And that change might be breaking because we're now adding stuff to that shape, and that means we're going to eventually need to release a new version of our API with that change included, which might take a little bit of time and effort to make sure we do correctly. But app developers need to be able to move quickly. We need, feature development is an iterative process, so we need to quickly lead and change our API as we change our views. And of course, if the client's going to need more data than it got from that initial response, then it's going to just immediately follow all those URLs that you just gave it and bombard the server. So now our server's sad, our app is slow, and everything just sucks. Right? GraphQL is going to really change this dynamic. First, it's going to express the full set of capabilities via its type system. And then clients are going to express their requirements, their needs, with their data queries. We've given clients the ability to ask for what they need within reason. It has to be within the bounds of the type system. And so now, rather than requesting specific resources, our clients are requesting specific data shapes. And this is actually a real separation of concerns. The server knows what's possible, and the clients know what it needs. And so now the server doesn't need to know anything about the client. And this means that as clients evolve and add new features, they can do so without affecting the server. Models and views, they remain coupled, but they have tighter cohesion because they now exist within the same code base. All right, so what does this look like in practice? Well, at Facebook, we have many different apps that all get data from one GraphQL API. And since we ship new builds of most of our apps every couple weeks, and we've been at this for 4 years now, we now have well over 1,000 older versions of these apps that, unfortunately, are still in heavy use because people don't upgrade, apparently. And they all hit the same GraphQL API. And 4 years later, we're still using version 1 of our API. We've never made a breaking change in 4 years. Finally, I want to mention a few things that GraphQL is not. Common misunderstandings. GraphQL is not a way to talk to your database. It doesn't replace SQL. It's not a competitor to Neo4j or the Cypher language, which I think is awesome. Languages for databases, they're going to have different semantics. The requirements that they have lead to different design decisions than what we had for web APIs. GraphQL is a way to talk to web APIs, and it's intended to sit atop your existing business logic rather than on top of your existing database, very much like you would do if you were building a REST API or any kind of web API. GraphQL is also not about formal graphs. There's no requirement to model your data in terms of nodes or edges or explicit relationships. And what we actually mean when we talk about graphs is the mental model that it lends us. We need this kind of interconnected data that makes it super clear of what we're doing in our apps. It's this natural interconnectedness of the data that we're using all the time that makes GraphQL relevant rather than some kind of graph formalism. And so maybe that helps explain where the name GraphQL came from. And so that's GraphQL. We're happy with what we've built. But actually, what I just showed you is super different from what we built 4 years ago. Getting to where we are now has been a long journey. And I want to illustrate just a little bit about what that process was like. So let's take a look at kind of like the history of GraphQL over the last couple of years. Hopefully this is insightful, and it can dispel any thoughts that ideas like this arrive fully formed. They definitely don't. First was the original idea. It came from my coworker, Nick Strock. He initially introduced this idea. He called it Supergraph. And Nick was actually one of the founding members of our team, Product Infrastructure. And up until this point, he had been responsible for the data fetching and the privacy checking abstractions on our servers, which made it possible for any view on Facebook.com to efficiently load safe data that we knew we could show the users without violating any privacy rules. And as we started working closely with more mobile teams, he had some ideas for how we could extend these ideas to our APIs. And he actually built a prototype of this in about 3 days. So from idea to initial thing that worked, pretty short. But next came the initial development of what would become the first version of GraphQL. I was already working with the iOS team on trying to figure out how to improve their newsfeed API, and Nick and I started to work together to adapt Supergraph to solve the newsfeed's actual problems. And Dan Schaefer, who was an engineer on the server-side team for newsfeed, joined our effort, and he really helped make this possible. And things happened pretty quickly from there. We evolved GraphQL to meet the needs of the iOS newsfeed, and within 3 weeks, we had something for that team to actually start using. And a couple months after that, we had actually completed support for the entirety of newsfeed. And then in August of 2012, we actually shipped this app. We shipped new iOS newsfeed. And as soon as other teams around our company saw, one, that it was fast, and two, that that team was actually excited about the developer experience, we started to get inundated really quickly with requests to extend GraphQL to more teams at Facebook. So first came photos, profile, groups, then events, and then quickly the rest of Facebook. So we actually, this is when we bothered to form a team around GraphQL, and we kind of, made it a little bit more formal. And during this time, really what we did is we focused on making sure that our type system still made sense as we continued to evolve it to support more use cases. And we also found a lot more varying use cases across our client teams. They were trying to do more things, interesting things, and we started adding features to the GraphQL language. And as we were doing that, it got complicated, and this was a long period of time, so it got really complicated. And in January of 2015, Dan Schaefer spoke publicly about GraphQL for the first time at the first React conference. And really, we had no idea what was going to happen. We thought people would be like, oh, OK, that's cool. You guys are doing that. But instead, we got this overwhelming reaction. We got tons of people asking us, when are you going to open source it? And we're like, whoa, 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 pump the brakes. We just wanted to give you a view into what we're doing. This was not supposed to be an open source announcement by any means. But the excitement was so awesome that it got us all fired up. We were like, yeah, awesome. When can we share GraphQL? Oh, wait, what does that even mean? GraphQL is super tied into how Facebook works. How are we going to untangle that? And also, we're not really proud of what GraphQL looks like now. We glossed over a lot of details when we did that presentation. All those quirks and inconsistencies and the assumptions that we made from the very beginning, they were all still there. So we decided to reevaluate, to redesign GraphQL. We made improvements, we fixed inconsistencies, and we redesigned both the syntax and the semantics of GraphQL. And that was a big project. That took many months, and it required a lot more deliberate and careful process, especially in comparison to the early kind of rapid pace of development that characterized our first few months. This ended with us open sourcing a specification for GraphQL, which describes how it works, as well as a new reference implementation that we wrote in JavaScript. And we did that not just because we like JavaScript, we do, but because it's a ubiquitous language, so as many people that could understand it as possible. And it lets us build tools on top of it. So the graphical tool that I showed you before is powered by our JavaScript GraphQL implementation. And any open source maintainers in the audience probably know what I mean when I say that open sourcing something is a beginning, not an end, right? We know that we're going to get a ton of feedback. And so what we did is we released GraphQL as a technical preview, just to set expectations that we knew things were going to change, right? Kind of the equivalent of oh, it's betaware. And over this period of time, we got a lot of implementations of GraphQL in other languages, all really by the community, which was amazing. And today, you can actually find an implementation of GraphQL in one of almost a dozen different languages. And that brings us up to this week. After a little over a year, GraphQL is being used not just at Facebook, but by lots of other companies. And earlier this week, I'm not sure if you heard this, but GitHub announced that its new public API is going to be powered by GraphQL, which was super exciting. And to reflect this, we removed the technical preview moniker, right? GraphQL is definitely being used in production, so we should make sure we're reflecting that. And we relaunched our website, graphql.org, to help teach people more about how GraphQL works and how to use it. So it's been a wild couple 4 years. I've learned a lot, and I want to share some of that, especially the principles that we use when designing GraphQL that helped us the most along the way. And I want to start with what's hopefully the most obvious. And that's when you're designing anything, a language or a library or a tool, it's critical to start with a single important problem to solve. For GraphQL, that was getting all the data that we needed for Newsfeed on iOS over increasingly terrible mobile network connections. And this basically completely ruled out using REST as an option. We tried this. We quickly devolved into lots of essentially custom JSON endpoints with resources mashed together in a way that just very clearly wasn't REST. So we had to abandon that for obvious reasons. Also, don't just solve any problem. Solve the most important problem you can find. 2012 was a while ago now, so I'm not sure if you guys remember this, but our mobile apps were truly terrible at that time. They were awful. In fact, when Zuck filed our IPO, our S1, he specifically called out the investor risk that mobile was going to drive an increasing amount of our daily users. This trend was already happening, and we hadn't figured out how to be good at it yet. So this wasn't a theoretical problem by any means. This was an existential threat to our company. Failure to adjust to major shifts like this, like desktop to mobile, has crippled or killed major companies in the past. Starting with an important problem grounds you. It keeps you honest about what you're trying to accomplish, and it helps you drive the early prioritization of ideas. And the most novel aspects of GraphQL, giving clients control of the data that they get, hierarchical queries, one-round trip, these were all established within that initial prototype in response to the problem at hand. So remember to stay focused on the most important problem that you're solving, and use that to crystallize what it is that you're building. Mental models. They're so important to how we think as programmers. Everything we make is ethereal, right? But there's lots of different kinds of systems and different kinds of programmers. And the mental models that we all use, they don't always match up. And an important part of designing GraphQL for us was being unabashedly driven by the needs of the client, the consumer of the language. Hopefully it doesn't come as a great surprise that a lot of great iOS engineers are also not top-notch network engineers, database engineers, or API designers. Our iOS engineers wanted to think in terms of the model objects that they were going to use and the JSON that they wanted to get from the network in order to hydrate those things. Those who take a trivial look at GraphQL, they usually accuse us of being database nerds, where we've got our database language hammer and everything looks like a nail, and then they see doom and gloom in the future. But in practice, I think it's really the opposite. We're product people. We work with product teams, and we design the API that we wanted to use to build products. So I think if you're designing a new language or a library or a tool, and especially one that connects different kinds of systems together, try to escape the mental models of how it works, especially how it works under the hood, and put yourself in the shoes of the person who's going to be using that thing. How are they thinking? And what is it that they're trying to accomplish? I love this tweet. Rethink established best practices. This was tweeted in response to us open sourcing React at a JSConf back in 2013. And I'm pretty sure it was supposed to be like jiding and like poking fun at us, but this has become a mantra for our team. Probably the most common question that I get regarding GraphQL is why we didn't just use REST, SOAP, OData, JSON schema, JSON API, RAML, Swagger, RDF, OWL, Cobra, or any one of the other things that already existed out there. And I think that just because a best practice or even just some other tool exists out there, it doesn't necessarily mean that it's the right solution to your particular set of problems. And none of these were right for ours. I do think that it's important to respect and honor best practices, and we evaluated all of these and even borrowed a couple really good ideas from a lot of them. But it's also important not to be held hostage by them. Elon Musk talks about this as reasoning from first principles, which I love. If you haven't seen this interview, it's pretty amazing. Please go watch it. And what he talks about is evaluate existing technologies, but really you want to boil things down to their fundamentals and then build them back up. And in order to do that, you need a good feedback loop. And speaking of having a good feedback loop, it's so important to have a first consumer of your library, tool, or language. Not like first consumers, a first consumer. When you're designing something new, it's really easy to find yourself considering all the possible future use cases or hearing tons of stuff coming from the crowd about all the things you want to be able to design for. And it's basically impossible to predict all of the details of what those are going to be in practice, and the devil's in the details. So otherwise, what ends up happening is you basically guess, right? You guess, and if you're wrong on those guesses, those decisions stick around and live in your language, tool, or library forever. That can lead to poor trade-offs and unnecessary complexity. So GraphQL's first client was Newsfeed for iOS. We embedded ourselves within that team, and we let their needs and priorities drive our decisions for how we were going to design GraphQL. And that encouraged us to provide an incremental adoption strategy as well, because they were already using the REST API before, and we couldn't just tell them to replace everything they had all written in one fell swoop. That wasn't going to work. They also weren't going to start over. They were under time pressure. And so what we needed to do was come up with a way for them to introduce this idea bit by bit, which ended up being super important, because as we expanded to the rest of the company, we were able to do that one little piece at a time. I actually think I don't have a separate slide for that, but the ability to incrementally adopt a technology is very, very important for it expanding in scope in the future. Speaking of adding features, your first response to every new feature request should be Yagni. Do you guys know what this means? If you do, you're going to say it with me, OK? You ain't gonna need it. I didn't hear anyone, so I'm going to do this again, all right? I want to hear this from everyone. What do we say to adding new features? All right, good. All right, good. Yeah. This is one of my favorite lessons, and honestly, it was the hardest for me to learn personally. Avoid implementing things that you foresee you need in favor of things that you need to solve a real problem today. The burden of proof should lie on the new feature to prove that, yes, truly, we are going to need it. Ask yourself, can we solve this problem in another way with the features and tools that we already have? And if we can, but it's awkward, just how awkward is it really? Can we live with it? Is it worth the cognitive cost? Every feature that we add to our libraries or syntax to a language, it's not just that it's expensive to implement. That's easy. It's more to learn and to teach. And it's also more things for new features that might come in the future to bump into. We may anticipate motivating reasons for adding new features, and Yagni is a way to keep ourselves from adding stuff until we truly know those details of what real-life examples are going to be like. And we're going to know exactly how common those are going to be. So if something totally sucks and we have one motivating example for why it sucks, but it's super rare, maybe that's OK. We need real examples to understand how to prioritize changes. And during the redesign phase of GraphQL, I was talked out of a number of proposals with this argument. And speaking of that redesign effort, it's really important to avoid the second system syndrome. This idea comes from the book The Mythical Man Month by Fred Brooks. It's one of my favorite programming books. It claims that the first time that you're going to build something, you know that you're a beginner. So you're just going to naturally be conservative. But the second time around, you have experience. You know what you're doing. You have success under your belt. And so you pull out all the stops, and you do all the things that you were too afraid to do the first time around. And then you end up totally over-designing it. As the primary designer of the GraphQL language, this was absolutely something that I suffered from. Yagni can help, but I think the even better way to combat this is to have an editor. As the designer, I have a propensity for ideas. I love to create new things, and I tackled this redesign with a lot of creative exploration, and I was gung-ho about all the ideas that I came up with. And if I was the designer, then my teammate, Nick Schrock, should be considered the editor. His role was to play devil's advocate, just to be like an all-around pain in the ass and argue against all my proposals. But in doing so, what he did is he identified the proposals that meant well and were interesting, but they just weren't worth it. And once I was able to convince Nick that something was worth it, he'd do a complete 180 and become a huge advocate for it. And this process also helped us clarify how we talked about GraphQL and the changes that we were making to it, which later helped us pitch them to the rest of the company, because, of course, the whole company relied on this. So changing the syntax and the semantics for a thing that we all relied on is not an easy thing to do. But ultimately, my editor, Nick, he ended up in the best position to persuade others of what we were doing, because he himself had been persuaded. And so if you consider yourself the designer or the architect for whatever it is that you're building, consider which of your coworkers you think of as your primary editor, because it's really, really hard to keep those competing mentalities in one person's head. GraphQL changed a lot in those first few months, and we were able to do that because we sat right next to the people that we were affecting with those changes. And later, as GraphQL was used across the company, it became harder and harder to make those changes. Change is still possible, even in a big company like Facebook, and we were prepared to open source GraphQL. And when we were talking about that, we realized that as hard it was going to be to change GraphQL now, it would be way harder when tons of companies were relying on this instead of just Facebook. And so while I had been interested in redesigning GraphQL for a while, it was really this open source momentum that drove the spark and motivation to actually make this redesign happen. I think most of us open source our projects way too early. I hope that's not too bold of a statement to make. I love and I deeply believe in open source, but I believe that it's the opposite of having a first client. If your idea is actually really great, then you're going to quickly get a ton of clients. And that's not necessarily what you want for a young idea that still needs space and time to evolve. It can make it difficult to prioritize. It also removes a lot of that freedom to evolve and be able to talk to the 1 or 2 or 3 people that you're affecting with that evolution. And finally, GraphQL could have not worked out. It was lucky and beneficial that it did work out for us, but it was a huge risk to build something new, especially at a time when we were really kind of facing an existential crisis about how we were going to turn things around from mobile at Facebook. And in my experience, solving a really important problem like this is typically the time when most engineering managers and teams and companies encourage sticking to what works and avoid what might seem like taking unnecessary risks. When Nick Schrock first shared his prototype of Supergraph, he got a fair amount of pushback exactly like this. But ultimately, we were allowed to prove the idea, mostly because of early enthusiasm from that newsfeed team we were working with. Some of the projects I'm most proud of at Facebook, they all started like this, including both GraphQL and React. And what I've taken away from this is not just to take risks, but in particular to trust experienced engineers like Nick to decide when that risk is worth taking and then hold them accountable for their choices. So especially if you run a team or a company, try to push decision-making and accountability to your strongest engineers, especially if they think the time is right for something new. So from Nick's Supergraph in 2012, to powering mobile newsfeed at Facebook, to open sourcing GraphQL last year, to GitHub publicly announcing that their new API is powered by GraphQL just this week, GraphQL has been through a lot. We're super excited about what we've built so far, but still feel like it's really just the beginning for GraphQL. We're still excited about continuing to invest in carefully evolving GraphQL to make sure that it has more capabilities and uses in the future. But even more from that, we're looking forward to the contributions from the community as GraphQL becomes bigger than we are. So if you're interested in learning more, please check out graphql.org. And thank you all for having me at Strange Loop. And I think I have like a few minutes for questions in the front.
So you mentioned that you did that refactor, that rewrite, and you changed some of the syntax. And you also mentioned that you haven't released any breaking changes since you started using GraphQL 4 years ago. So how did you manage to not have any breaking changes in your clients, but also change the syntax?
Great question. So the question was, how did you manage to change syntax and semantics of the language, but then also not have a breaking change to the API? So I should clarify a little bit. We've never made a breaking change to the data aspect of the API. And in doing what we've just done, that might be considered the first time that we've introduced a v2 of the API. But we're actually still working on that internally. So even though it's been open sourced for a year now, internally we're still working on adapting all of our systems to the newer version of GraphQL. And in doing so, it's been we open sourced that a little over a year ago. So it's a long, involved process to do that kind of iteratively and step by step and making sure that we never break anything along the way. But we are in the process of setting up a new server. And what it'll do is it'll actually accept both the old and the new language. And when it receives the old language, it will first quickly transpile it to the new language and then run the new query. And that allows us to still have one endpoint, receive queries from all these different things, and accept both. But yeah, that's probably the first thing that we've done that's a breaking change, is actually just like redesign the entire language of GraphQL. But we've still never made a change to the actual type system and the data within GraphQL. Other questions? Yes, I see a bunch of hands. Somebody please shout. All the way in the back there, yeah. Great question. So the question is, say you want to take a GraphQL front end and wrap it around some REST APIs, and you're going to make a bunch of requests and then stitch them all together in the process of resolving a GraphQL request. Will that be slow as the slowest REST request, dependent REST request? Yes, probably it will, because you need that data in order to fulfill the request. So you will wait on the longest of those requests in order to make it happen. One of the experiments that we've been playing with in GraphQL, and it's still very early days from this, so certainly don't expect anything in the very near future, is to add the ability to take one GraphQL query and then describe pieces where you say, this subtree of the query I care about, but I don't care about it coming immediately. So I want this piece before I want that piece, and that gives us a little bit of streaming semantics to sending the requests back, or the responses back. So we're playing with that kind of idea, and we don't have anything like that ready yet, but something that we have to kind of tackle that kind of waiting on the longest piece of data problem. Yes, in the back there. Great question. What happens if you're loading lots of stuff and one thing has an error? We have built into GraphQL, and we did from the very beginning, a way to handle errors. And in fact, if you start reading more about GraphQL, the first thing that you might see as type system people and go, that seems weird, is that by default, types in GraphQL are nullable. And you actually have to say that something is non-nullable, which is usually totally the opposite of what you would do in a type system. You would have the type, and then you would say, and then here's the type, or it's null, right? Or like a maybe. So it's the inside-out maybe type. And what that does is it makes the assumption that any field in the request might fail. And if the field fails and it's nullable, that's fine. You can return null in its place. And then we sideload a list of errors that occurred during the preparation of that query. So we can say, blah, 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 you load friends, you load events, and at some point in that, you hit a privacy error and you weren't allowed to see that event. Or this database was down and it dropped this particular profile picture. Or whatever, something happens. You don't want to bork the entire query. You just want to bork that subtree that's not possible. And if something isn't capable of being null and it has an error, then it just simply bubbles up until it finds the first thing that does. So a good example of that is if you have a newsfeed story, the actor is probably something, the person who posted the newsfeed story is something that should be there. It'd be really weird if you saw a newsfeed story show up and it didn't have who it was from. So we make that not nullable, and if an error ever happens during the preparation of the actor of a newsfeed story, then we just null the entire newsfeed story, and we report that error to the client as well. Great question, though. Any other questions? I think I have time for one more. Here.
Is there any plans for subscriptions or streaming data?
The question was, are there plans for streaming data or something like subscriptions? Yes, we have a bunch of experiments that are dealing with this. They're still early days. We actually have deployed some of those at Facebook. So even though it's early days, we're actually really using in production these experiments. So we have two different ways of thinking about this. One we call live queries, which is the ability to say, here's a whole query, and then if any piece of the data anywhere in that query changes, send me a diff with that update. And you might think about that as like React for your data on the server. Maybe a mental model to think of that. And then the other is subscriptions, which is layering GraphQL on top of a pub subsystem. And that is one that we actually have in production. And if you have ever commented on Facebook, both on the web and on or your iOS or Android device, then you have seen GraphQL subscriptions in actions, or in action. It also powers our live video feature. So if people are like commenting and like doing stuff during a live video, that's all powered by GraphQL subscriptions. So we're still trying to figure out, like, that's evolving quickly, and it kind of leads back to some of the lessons I was talking about of we like to keep some of these things experimental as possible early, because we've already changed that system a lot. And we want to make sure that we don't say, like, here's a great way to do subscriptions. Psych, it doesn't work for all these reasons after you've all implemented it. And so we want to make sure that we really get that right before building it into GraphQL. All right, thank you guys all for having me. It's been a pleasure.